Professor Dr. N. Ganesh is working as a senior faculty, Department of Computer Science and Engineering, SRM University, City Campus, Vadapalani, Chennai. He has more than 12 years of undergraduate and postgraduate teaching experience, which includes 5 years of research experience. He has trained many corporate batches on technologies such as mainframes, Application Systems 400, SAP, ABAP. He has published 10 articles in both international and national journals. He has presented several papers in both national and international conferences. He has written 4 books which are prescribed in Anna University affiliated colleges, SRM University and Bharat University. His research interests are software engineering, data mining and cloud computing.
Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating systems. This subject is for the students studying in their 5th semester of their BSc degree program. This operating system belongs to paper number 8. In today's lecture, we are going to see few topics from unit 2. In unit 2, there are several topics, out of which we are going to see topics on the semaphores and the classical problems of synchronization, and then about the process synchronization. In our previous lectures, we have seen topics on process synchronization. In this, we are going to continue the previous lecture, in which we are going to see the process synchronization, the semaphore. In today's contents, it will be like we will be seeing semaphore, the semaphore types and its semaphore implementation. As well, I will be giving you a few details about deadlocks and starvation. We have already seen deadlocks and starvation in one of our earlier lectures. So, I will be relating this deadlock and starvation with the present topic. Here, now, what is a semaphore? You would have had an experience in traveling trains, and you would have seen the railway tracks. How the railway tracks look like? How the trains, you would have seen even the signals that has been put on the railway tracks. So, how does it look like? So, here is an example, and this wherein this point, this is called as a semaphore, wherein this is said to be a signal. If this signal has been put on a horizontal means, which means both the user or the commuters, or we can use the railway tracks. How can we use the railway track? In terms of making a crossing between the tracks. If you want to make a level crossing, if you want to go into a level crossing, then that could be done, supposing if the signal plate has been put on a horizontal manner, and even the human could use the railway tracks. So, now how do we relate this example with the operating system semaphore concept? Here, so this is called as, the signal is called as a semaphore concept. This type of signaling is called as a semaphore concept. So, how do we relate it with respect to this particular topic? Here, let us consider the railway track is said to be a resource, right? And the human beings or the trains or the cattles or even the car or bike or buses are said to be the processes. So, supposing if the resource is free, then the process can use these resources. Then, supposing the resource has been occupied at one single instance of time, only one particular resource can occupy it. That is, in a single railway track, only one train could move from a from one particular station to another station. So, and we cannot, supposing if some other process is going to interrupt when the train is coming in on the track, supposing if a human being or a cattle comes in between, then this train, it will not stop, it will just like that, it will dash away the human being or the cattle, whomsoever it may be, and then it will see to that it is completing the process, and then it reaches the destination. Now, I suppose from this example, you could infer what is the real meaning of a semaphore is. A semaphore is which allows the process to take place, to work into execution, to occupy the resources. So, this semaphore checks whether a particular resource can be occupied or can be used by a process or not. That is called a semaphore. That is the literal meaning of a semaphore. In this example over here in the signal is said to be on a horizontal means, which means human beings or even any other example can pass through. Supposing if in the other case, if it is like this, wherein the signal, it has been put on a vertical means. If this has been put on a vertical means, and I suppose even you could see a red signal over here, this is said to be a newer version of the signals. Nowadays in many of the railway tracks, we have the signals as the LED or the LCD lights, wherein we have all sort of red and green signals. But in the earlier days, we have signals such as only we have handmade signals. So, handmade signal is, this looks like a hand, and if it is on a vertical direction, then which means the human beings or the cattle or any type of vehicle should not transmit on the process, on the track. So, that is because this is an indication which says that this track has been reserved for the railway, for the train to cross on this track. So, when it has been put on a vertical mode, it means that it cannot cross from this particular, that is other than the train, no other thing could cross. So, here when the semaphore is been put on a state in which, supposing if a signal has been given on the semaphore, it means that a particular resource could be occupied, that is a particular resource has been reserved for a particular set of process. Supposing if P1 and P2 are going to make a request for handling the printer, if they wanted to handle, if they wanted to execute, or if they want to use a printer, then this process P1, if it has ordered for the first sequence in the sequence basis, if it has ordered pretty earlier than P2, then this P1 process will be allocated a resource, the printer resource. So, at that time the P2 should wait, and no other process should ever think of using this printer resource when it has been allocated to P1. So, this semaphore helps, or it monitors whether the process, whether this resource can be used or not. So, this is used for allocating a resource. So, in this example wherein you have this signal, hand signal that has been raised to the top, that has been put on a vertical manner. So, this track has been reserved for the trains to pass. This is called as a single semaphore with single trains being passing. Supposing if you are going to see for supposing if two or more number of processes are going to execute at the same instance of time, if they are going to execute at a parallel basis, then we would have in our earlier lectures, we would have seen a concept of multi-processing. So, two or more number of processes executing at the same instance of time on a parallel basis. Here in a single processor, it has been done on a sequential basis. Supposing if one train is going to cross on the track, the other train has to wait till the first train crosses. So, the second train can commute only when the first train has passed away on the track. Whereas in the case of multiple processing, two trains can pass on a simultaneous way, but on a parallel basis. This is single process to be a sequential basis or a serial basis, whereas in the case of multiple processing, it is of a parallel basis. So, this is an example to state the multiple semaphores, wherein you have two or more number of signals that is been put over here. So everything is put on a horizontal means, what does it mean? It means that both commuters as well the vehicles could use this kind of tracking. So they could use this railway track in such a way that both vehicles as well the commuters could make a level crossing of it. So that is what is an horizontal hand signal means. So this is an example for multiple semaphore, wherein one train could pass in this first track, and at the same time second train could pass in the second track, third train could pass in the third track, and so on. I suppose you would have seen in the railway stations, in the railway junctions, for example, you would have seen multiple trains standing at the railway junction at the same instance of time. So for each and every train, they are going to use their own railway track, and train 1 is going to use its own railway track, train 2 is going to use its own railway track. But at the same instance of time, two trains can start its movement at the same instance of time. That is called as a multiple semaphore. At the same instance of time, two or more number of processes can start and they can go for execution, but on a parallel basis. So this diagram, this figure shows a multiple process, multiple semaphore. So by and large, for a semaphore, what are things that are required? A semaphore, we require two functions. One is a signal function, second one is a wait function. So what do you mean by a signal function and what is a wait function? A signal function is one. Supposing if a signal is given, this resource has been allocated to some other process, so no one can use it. A wait function is one. Supposing if a wait function has been given, then anyone can use that resource and the process will not be asking for it. Any other process which has been asking other than the process that has been asking could use the resource. That is called a wait function. Now what is a semaphore by and large? A semaphore is an integer value which is used for signaling among the processes. So there are only three operations that are possible. One is initialization, second one is incrementing, third one is decrementing. Increment, when you do, it is called as a semaphore signal or it is called as a sem signal. When you decrement it, it is called as semaphore wait or sem wait. So let us consider a different example. Here in this example, supposing if you have two kids, two sons, and if guest 1 is going to come and if they are going to bring certain chocolates for your son, and if they are going to get only one chocolate for your son, then what will you do? You will give that chocolate to the first son, and then what will happen? The second son will be waiting without a chocolate. So he may also claim for a chocolate. So what you need to do is you will be asking him to wait for a few instants of time. Then supposing if a second guest also comes in, and even if he brings in one chocolate, then you give him, then you take the chocolate from the second guest and you give it to the second son. So now till the second guest comes in and till you give your chocolate to the second son has been put on a wait. So that is called a semaphore wait. The first son, he has got it at the first instance itself. So let us consider the chocolate example as C equal to 1. So let us assign a variable for a chocolate as C. Now C equal to 1. So the first guest comes in and he gives the chocolate. So this guy, the son who is waiting, the first son who is waiting for the chocolate, he gets the chocolate and he consumes it. Something like a producer consumer problem. So this first person produces, the second person consumes it. So here the producer consumer problem we have seen in one of our earlier lectures. So here the first son consumes it, then till that the second son has to wait in queue. So now let us see how the second son waits and how he consumes the chocolate and what happens to the C value after the break. Welcome back after the break. Before the break, I gave you an example with respect to a guest coming in and he is giving you a chocolate to one of your son. We were speaking with two different sons. I said you have two sons, for example. Then that guest comes in and he gives one chocolate, and to whom will you give the chocolate? So supposing if both your sons are asking for the chocolate, and if the first son and if son number 1, if he has made a request, if your elder son has made a request pretty earlier than your younger son, then when the guest gives the chocolate, you will immediately give it to your elder son. Then when second guest comes in, you will be giving the chocolate again you will be getting the chocolate from the second guest and you will be giving it to the second son after the second guest gives the chocolate. So till that period, the second son will be waiting in the queue till a second guest comes in until he gives a chocolate. Now let us have a variable, assign a variable for the chocolate. So let us assign the variable as C. So initially the two sons are waiting with his father, and if no guest is coming, so the C value becomes 0. So when the first guest comes in with a chocolate, and if it has been allocated or if it has been had by the father, then the C value becomes 1 because one chocolate is available. But for the first son and for the second son, they did not get the chocolate as of now, so it is only 0. So this first son, he gets the chocolate, so the C value becomes 0, and he gets the chocolate, so the C value becomes 1. So after he eats the chocolate, then the C value again becomes 0. So likewise the count value increases and decreases. So this is what an incrementer and decrementer means. So when the first son eats the chocolate, the C value becomes -1 for the second son because he did not get any chocolate from the first guest. So after the first guest leaves, when the second guest enters in, he gets the chocolate and he eats it. So the C value for the second son becomes 0 now. From -1 plus 1 becomes 0. So this is called a semaphore increment, a semaphore decrement, and since he is in the waiting period, we call it as a semaphore wait. A semaphore is a signaling thing wherein we wait for a particular resource for a particular process to occupy the resource. So it is an integer value. It cannot be any other value. It can either be an integer value or it can be a binary value. When it is of an integer value, it does not have any demarcations or it does not have any sort of limitations. The integer value can range from 0 to n, whereas if it is a binary value, the limitation is it can hold values only either 0 or 1. Now let us see, a semaphore is a synchronization tool. Synchronization is a process synchronization tool that does not require busy waiting. So this semaphore S is an integer variable. Two standard operations are, one is wait, other one is signal. It is less complicated. So when you have a semaphore, it is useful to say when this process completes this resource and when that resource is been left free. So to indicate that we have this kind of semaphore, and then in this semaphore, the semaphore is of two types. One is called as a strong semaphore, other one is called as a weak semaphore. What is a strong semaphore? A strong semaphore is one wherein it has been queued and it has been given on a FCFS basis. What is FCFS basis? It has been given on a first come first served basis. So a strong semaphore. Again, let us get back to the old example of having two sons. So when you are going to have two sons, and when the elder son has made a request pretty earlier than the younger son, which means the request made by elder son is said to be is being given the first priority, and then the younger son's request is being given to the second priority as a second priority. Now the strong semaphore is you get the chocolate from your guest. So it is you as a parent has to decide to which son you are supposed to give it. If you are going to give it to the first son, because since he has been made the request at the first instance, then we say that it is called as a strong semaphore. Supposing if, let us consider there are 4 children, out of which first 2 are your sons, the remaining 2 are your neighbor sons. So what happens here, in which third child who is standing in the queue is said to be the youngest of all the other 4 or of all the other people. So in which here, supposing if we, let us consider, if we said to be very young in the sense, if he is somewhere around 2 years old, wherein the other children are in the age group of 3 years, 5 years, 7 years and so on. So in this case, a guest comes in, you get a chocolate from the guest, and you are supposed to decide, make a decision to whom you need to give the chocolate to. So supposing if you are going to give, so with this, with all these 4 children, if the younger child who is of 2 years old, if he is going to cry and if he is going to ask for the chocolate, you have every right to give the chocolate to the child who is crying, who is pretty small. So this is called as a weak semaphore. You are not queuing, you are not prioritizing, you are not assigning anything. You randomly pick a process, you allocate it to a resource. You randomly pick the child, you give a chocolate to him. So that is called a weak semaphore. So here it is, in the case of strong and weak semaphore, a queue is used to hold the processes waiting on the semaphore. So now even I have posed a question, in what order are the processes removed from the queue? In the case of strong semaphore, we use a FIFO basis. FIFO is first in first out basis. In the case of weak semaphore, we do not specify the order of removal from the queue. So we assign it on whatever means we want. So based on the request, supposing if there are 4 children and if one child is said to be your child, then obviously you will give more priority to the child than when compared to other child. So first of all, you will settle his hungerness, then you will listen to other child. So but that is said to be a weak semaphore. So now let us consider this with respect to an example with relating to an operating system. So here is the example which states about a strong semaphore mechanism. Here we have a processor. So let us consider this. I said the semaphore variables, it should be of an integer value. So let us have s equal to 1. So in this example, these are the processors A, B, C, D, C and D are said to be the processors. So let us assume this D, this process D is producing some output, and this output is being consumed by this B and C, A, B and C. So I will repeat, this D is going to produce some output, even this is said to be a process, but the output that is being produced by D is being consumed by A, B and C. So now in the initial case, since this is being queued out, it has to go only via first in first out basis. So now the semaphore s equal to 1, wherein this A is being put on the processor, so it gets processed out and it uses the output produced by D. Here now the second chance is for B to enter into the processor. So now the B enters into the processor, but the A has consumed the output that has been prepared by the process D. So, in that case, when A has consumed the output, S becomes 0. In the earlier case, S was 1. In step 2, S becomes 0. So, this B is waiting for the output that is to be produced by D. One and only if D produces the output, the B could execute its process. So, what happens here is this B will be put on a queue, on the blocked queue. This B goes into a blocked queue and it waits. So, now as far as step 2 is concerned, it is a chance of D to make its execution, to create an process, to create an output in order to be consumed by B or C process, because A has already consumed, it has left. Now, this B or C has to consume it. So, here this B is been put on a blocked queue. So, it is waiting. Now, this D produces an output and it is not using anything. So, S becomes minus 1, 0 minus 1 becomes minus 1. Then, this value, this B, it gets released from the blocked queue and it uses the output that is being produced by this D. So, but even if it is going to get produced from D, if it is going to use also, then again it has to move via a queue. So, this after using this output, this B will be placed over here in the ready queue. When it is when your process is in the ready queue, where will it be? It will be stored in the main memory. So, a ready queue is a location where all your process gets stored in the main memory and which is ready for execution. A process is a program in execution. So, now this B gets input from the output that is being produced by D. So, D's output is said to be B's input. So, it processes it, then S becomes 0, S minus 1 plus 1, minus 1 plus 1 becomes 0, then it uses it, then again after blocking it gets released from the block and then it goes to the ready queue B. It goes to the ready queue and it is put in the third position. Now, the semaphore value is again it is 0. So, C requires the output of D. So, wherein D has not produced any output now, because the output that is being produced by D is being used by this B. So, C has to be put on a blocked queue. So, now C goes to a blocked queue. So, what happens? Then again when C goes to a blocked queue, then because it is waiting for the output to be produced by D. So, it becomes 0 minus 1 becomes minus 1. Now, here we have an A. A again goes inside the processor. A is also waiting for the output to be produced by D. So, it again goes to a blocked queue. So, minus 1 minus 1, minus 1 minus 1 is minus 2. Then B goes to a processor. B is also waiting for the processor D to produce the output. So, minus 2 minus 1 it becomes minus 3. Now, here C, A, B gets stored in the blocked queue. Now, this D goes in, it produces the output which is being consumed by this C. So, here in this step number 6, this D, when it produces the output which is being used by this C. So, now S becomes minus 3 plus 1, it becomes minus 2. So, what happens here is then again this D has to produce an output in order for the A to use it. So, minus 2 plus 1 becomes minus 1, minus 2 plus 1 is minus 1. Then A uses it and A comes to the ready queue. Then again D has to produce an output, then that output will be used by B. So, minus 1 plus 1 becomes 0. So, now all these processes gets completed. So, this is an example for a strong semaphore. Now, let us summarize whatever we have seen in today's lecture. So, we have seen what is a semaphore and what is the meaning of a semaphore and what is the purpose of using a semaphore. We have learnt about the operations carried out by a semaphore. There are three different operations. One is increment, other one is decrement. The first and foremost is said to be initialization. So initialize, increment and decrement are the three operations that has been carried out by a semaphore. Then we have discussed the different types of semaphores. One is a strong semaphore, other one is a weak semaphore. We have as well learned how the semaphores are implemented on a real-time basis. Now let us see what are the possible questions from this lecture. The questions are: number 1, what is a semaphore? What are the operations carried out by semaphore? What are the types of semaphores? What is a strong semaphore? What is a weak semaphore? So these are the questions that are possible from today's lecture. So with this we conclude this lecture, and we will see more details on about semaphore in our forthcoming lectures. Thank you.